Hey everyone, super stoked to be here. I am very happy to be back in the Pacific Northwest. I'm from Vancouver, and I've been in San Francisco, and it's been pretty smoky lately. So we're going to basically write a bunch of code today. Oops, I meant to do that in Node. Anybody know what happens when you do this? It's pretty funny. Mostly I just want to see, it's like, oh, that's a terrible typo. Whoops. I wanted to see if my screen's readable, which it seems to be. So JavaScript's not so great at math. We're not going to talk about that today. We're going to talk about functions. Is anyone in here deploying AWS Lambda into production today? Okay, quite a few. Right on. So I'm down with making this a little interactive so you can yell at me. What's the #1 problem right now with serverless? Cold start? Cold start's one. Anything else? Sharing code. Okay. All right. Those are pretty good. We're going to touch on both those. I would postulate the actual problem with serverless is nobody cares. Nobody cares. So you can deploy a static website today to just about the entire internet in a few seconds. It'll be available to just about anybody in about 10 milliseconds. You use GitHub Pages, you could use Netlify, you could use Surge. And then the back end, nobody cares. We do these things, and there's no real motivation for this. And I think a lot of people are getting into the serverless world, but they're wondering why they're supposed to care. And so my job today is going to be to try and demonstrate to you why you might care. And I'm going to do this in probably the most inadvisable way possible. I'm going to live code everything. So this might go really wrong. Let's just hope the demo gremlins are on my side. So CascadiaJS. I can't see that and not think CommonJS. I'm going to touch what's called a .arc file. So this is how I'm building serverless apps. And the idea of an arc file is that it's a manifest format. A lot of these serverless frameworks are using YAML, and I'm not down with that. So we're just going to do something else. So I'm using this project Architect, which is this rock I've been polishing for about 2 years now. We're reaching into the internet to grab it from NPM. And I know one of you right now thinks I should be using Yarn. I know. It's OK. It'll be over soon. Almost installed this. Great. Not bad, 211 packages. I love the reuse of that. So we've got this empty node project without too much going on. Oops. So there's my arc file. And there's nothing in here because I haven't done anything yet. So the syntax of arc is pretty simple. You define an app, which would be a namespace. So I'm just going to do CJS. And then you can define routes. And these are going to turn into individual Lambda functions. So let's do that. We'll just do one route for now. And I'm just going to create this locally. So Node 6, I believe, shipped this tool called NPX. And NPX is pretty wonderful because it lets you run binaries local to your project. So instead of installing like a global binary and having it all over your system and not being able to deal with it, you can just use NPX and run these local binaries. Whoa. So I'm just going to not open my node modules because that's a bad idea. So when I ran that create local command on this file, it kind of mirrors the file system where I get this HTTP thing, and I've got this function right here. I'm sorry, this is hard to read, so let's just make this a bit smaller. OK, so this function just says, hello, Cascadia. And I'm going to start a local sandbox, and we'll take a look at that. Great. OK, so we're running one function locally. No big deal. Let's add another function just to make this a little more interesting. So we'll go into the arc file. And we'll just do a get foo. npx create local. My terminal is not super stoked on this resolution, so it looks a bit funky. But that's OK. And we'll run the sandbox again. Great. Whoops. Not that. We go foo, see hello world. It's kind of what you would expect. OK, so working locally is a thing, but really we want to work in the cloud. So npx create local tells Architect to build that thing to your local machine with an in-memory database so that you don't have to have an internet connection or an Amazon account to prototype. npx create by itself will generate 2 API gateway instances, 2 DynamoDB tables, in this case 4 Lambda functions, and it'll deploy the whole thing and then wire it up with an IAM role. The reason we do 2 of everything is because we want to have staging and production environments out of the box. So this isn't something that you can really opt out of. If we're building software today, we want these isolated spots where we can stage our deployments through a development process. A lot of other systems that are out there kind of make you do this yourself. You inevitably don't quite do a great job of it. It means that the systems are not quite the same. You end up having a checklist when you're deploying to anything because you might have to do something manually. And your environment's not being the same means that you have a tough time reproducing bugs. And if you have a hard time reproducing bugs, then you definitely will have a hard time resolving them. So this part takes like a minute. But there we go. We're live. And this is a Lambda function deployed at this pretty URL. Woo! And if we look, foo should be live with that hello world. So not too bad. That took about 2 minutes. Let's get iterating on this because I'm running out of time. So maybe I want to, play with the session, let's say. And so we're going to add a route called post count. And I'm going to go into my index module. I'm going to add a form. And we'll leave this here. I'm just going to be that guy and totally make a messy thing here. So we'll post a count. Yeah, totally that guy. It's OK. It's a demo. I'll add a button, type equals submit. One up. And we're going to add a method to that. Great. So that will post to a route called count. And we added count here, but we haven't generated it yet. So I could generate this live right now into the actual Lambda functions servers thing that we've deployed, the API gateway thing. But we'll just do this locally for now. So the create function's indemnifant, which is a fancy way of saying it can be run and rerun over and over again. It's not going to clobber anything. It only creates stuff if it doesn't already exist. So that's pretty quick. We got that. Actually, let's take a look. So let's boot up our sandbox again. You notice that sandbox starts super fast. So that's what you want. No waiting for builds. Great, we have a button. And if we click it, we go to this place called count, which is not so interesting. So let's go take a look at that count function. You'll notice these functions so far don't have any dependencies. They're just functions, which is kind of nice. So what we want to do here is actually redirect. So that's a status code of 302. And for a location, we'll just go home. Whoa. Gotta love the new keyboard. These Macs. Oh. We'll pop back over here. Oh my God, this keyboard. OK. And that probably redirected, but I didn't see it because I'm old. Let's see. We'll pop up the network. Yay. So we're getting a 302 redirect, and then we're coming back home. That itself is not so exciting. let's start playing with state. So one of the problems with Lambda functions is that they're totally stateless by nature. It's not really so much a problem as it's a feature, but at some point when you're building an application, you're going to need a session state. So we're going to want to get one of those. We bundle a couple of helper functions for this purpose. Our architect functions. Payload is small for this, by the way. So if I wanted to get some state here, I could do like wait arc.http.session.read. We can log it here just to take a look at it. And I'm going to say session.count equals session.count or 0 plus 1, and then we redirect back home. And then back on that home handler, get index. Oh my God, this fucking keyboard. How many times a day do I have to say that before I buy a Surface Book? It's getting closer every day. Okay. I'm digging this new Microsoft. So same pattern. Gonna pop open post count and just steal that line of code. I know this is pretty messy, so close you. So this is gonna read that session, and it's gonna look for, well, actually, you know what? Let's just be super weirdos, and let's just dump the whole thing out. And this is like one of my favorite debugging techniques. Let's just dump the whole request. No, we'll dump the session. Let's do both. We can do both. Okay, I got a typo in here somewhere, don't I? No, actually, I just have bad syntax highlighted. Good. Okay, so when we redirect, this is going to come back, and it's just going to dump the session. It's not going to do anything else. Whoops. So let's sandbox this so we can see the login a little cleaner. Great. Oops, wrong way. And session doesn't have anything on it yet. Oh, I did something wrong. You can see my session state is not persisting because my ID is changing. Sweet. You gotta love it when the demo gods come and get you. This totally worked like an hour ago. Okay. We're gonna do some live debugging here. I know what it is. This is like when I lose my keys. The only way I can find them is if I tell my wife I lost my keys. And then I'm like, oh yeah, no, I know where it is. So I assigned the session here, but I didn't save it because I'm dumb. All right, so what I want to do here is get a cookie. And I'm going to say await arc.http.session.write session. And then I'm going to write that cookie onto the request. That was the missing piece. Helps to persist things if you want to see things persisted. Okay. Oop. And there we go. You can see down there, our count is incrementing. Hey. So that's local, though. That's not very exciting. Like, let's deploy this thing. So I didn't create all these routes yet, so we're going to run this again without the local flag, and it's going to deploy it to Amazon. And we can check it out there, just see how we feel about that. You'd think Amazon would be fast at Amazon. I'm kidding. Amazon's actually shockingly fast all the time. What it's doing right now is it's walking through that ARC file, and it's making sure everything's in sync. And it's creating assets if they don't already exist. And so, it takes a moment because I'm looking at every single resource in that ARC file and generating those things twice, once for staging, once for production. Once you've done that, the deployments are actually shockingly fast. These functions, because they're tiny little bits, they can be deployed in parallel, which means that if you have a whole bunch of functions, you're basically only rate limited by whatever you're paying Amazon. So in theory, It's infinite, but you're actually bound by how much room you have on your credit card. OK, so that deployed. Hi, Michael. Oh, that didn't deploy. That generated. So we already generated that home route, but we actually didn't deploy our local changes yet. So we'll run that. And this is a resolution thing. Usually that progress bar looks, actually, that looked kind of cool. I'm here for it. So if we reload that, exact same thing that we had working locally is now running remotely. You can see we get this whole big whole request object. And oh no, it blew up. And I actually expected that to happen. So Amazon, for whatever reason, when you deploy API Gateway, it appends these sort of funky URLs, which is annoying because you want to work at the apex of your domain. So the way to fix that is to set up DNS. Another way to fix that is to hack the URL. So I'm just going to do that real quick. Helpers.url. And so you don't need this function once you set up DNS. And setting up DNS, honestly, it just takes not long. So I deployed 3 functions there in 4 seconds, which was pretty OK. You can surgically deploy 1 function if you want to, and that was the post function, I think. So we'll just deploy that one. Great. We've overwritten that function. So we should. Really? Oh, I know why. I have to fix that form as well. It's the fun of live coding. You get to be along for the ride of watching me flail this. That's how you know it's real. All the mistakes. OK, so this URL is ostensibly the problem. Is this reading OK for you back there? OK, cool. We're JavaScript devs. We're used to it. A little bit messy syntax. I love it. We'll just deploy the whole thing, because who cares? It's like 2 seconds difference. Great. Let's test that. Oh, not dash. OK. Staging. Yay. And oh. Count of 1. Count of 2. Sweet. So that's cool. Let's deploy that to production. And this will just take that same code and basically just pump it straight into a fresh set of lambdas and a fresh API gateway. And these things are entirely isolated from each other. They're not touching each other in any way. You'll notice that cold start was non-existent. So something that people brought up earlier, one of the problems of these things is the cold start. Cold start's not a problem if you have lots of small functions. The key is to be under 5 megabytes. And this is pretty common knowledge now because I've been saying it for 4 years. OK, so I've only got a few minutes. I'm going to cruise through these last few slides. I think you can now maybe see that there are reasons to possibly care about serverless. The function is the key here. And there's a lot of things calling themselves serverless today, and that's fine. They can do that. But if you really want to see the benefits of this type of architecture, lots of small functions is definitely the way to go. And one of the sort of big anti-patterns a lot of people have been doing is they'll take a function and they'll put an express web server in it and they'll deploy that one function. And it's a really bad idea. And I know because that's the first thing I did with our startup. And it worked for quite a while. But the moment that you deploy an express web server in one function, the very first moment is the very fastest that thing will ever be. Because you're just going to keep adding code to that thing, and it's going to get bigger and bigger and slower and slower. So the key here is to break it up into lots of small functions, which I think you get. So it's cool. Lambdas have a lot of nice characteristics. People call this only pay for what you use 100% utilization. I don't know why we call it that. Just call it, you only pay for what you use. And by the way, what do you pay? Well, 1 million executions is free, and then it's like a penny for every million executions after that. And so it's not free, but it's very affordable. Lambdas have a way better security model. They're locked down by nature. They only execute for 100 millisecond increments. When they go away, there's no ports to scan. You control the dependency packages as they go, and then they go away. They're stateless. So each function can also be independently configured. So with a monolith, if you're setting it up properly with IAM roles, you're going to try and have least privilege, which if it's a monolith, least privilege will be you can do everything. With a Lambda function, you can lock that thing down very discreetly. So GET requests can only read, that kind of thing. The big thing is that we're only focusing on business value. So a lot of time gets spent on infrastructure. I don't know that this crowd cares about that as much, but I know that the big enterprises do. So to me, fast or functions or lambdas or whatever we want to call them, these are best in class. They've got fixed costs, they've got better security, and you just get faster iterations, as you could see. These things are so fast to deploy. So we have a roughly 150 Lambda web app, and our deployment time is about 40 seconds, which is pretty amazing. So you can deploy these things in a few seconds, but you can also deploy them all in parallel. You can deploy them surgically. And this means that you get more iterations. And if you get more iterations, then you probably have a better chance of fixing that bug or finding product market fit or building that next feature. And speed is kind of the key. So your author time is faster, your runtime is faster, your bug resolution is better. It seems like it's pretty worth exploring. I also want to put out there that we should be a little more excellent to each other. There's a lot of people saying that they have the right way to do this, and I don't know that that is true. But what I do know is that the back end is now yours. You can build all that stuff, and you really don't need these servers or Kubernetes or any of it, which is a pretty big deal. So if you want to get involved in this, we like pull requests. That is definitely contributing. But bug reports are actually, like, please report bugs. I had someone I met just a week ago, and they were like, oh, I had a bug, but I didn't want to say anything. I was like, no, it's like the worst. Like, please tell me. Feature requests are also appreciated. I don't have all the same use cases as you, so please let me know and share what you're learning. And thanks very much.